thrilled to be here. Looks like the hall is full. I was wondering that, what's going to happen with the Bangalore traffic. Sounds like you guys have figured out how to predict Bangalore traffic. Of course, you guys are all data scientists, right? Have you figured out how to predict? Not yet, right? What I want to talk about is how analytics and AI has become a full stack business. Whether you are a professional figuring out what to do next in terms of skilling yourself so that you can, up your game in the market, or whether you are an investor looking to figure out which is the next big idea that is going to get better value for their money, or you're a business owner in a large enterprise and looking to figure out how do I solve this particular problem, because every time I deploy a team of data scientists, they come back to me with some outcomes that I can't use. So what do I do, right? How do I think about it? And the key here is with the advent of AI, with machine learning, what we are really going to see is the cost of prediction eventually is going to become very low to zero. Now, does that mean that machines will be able to do everything? Right? Outside of this room, people who are not so familiar with AI or data science do believe that that's it. AI will replace all the jobs and we can probably all party maybe, right? But that's not happening, right? The key here is how do you really create those actionable insights through prediction, right? It's not about what's the next best technology we can use, right? It's not about that. Now, what's happening, the transition that I am seeing, and I've been, by the way, I bet my career 12 years ago on AI when AI was not so sexy. But we stumbled into it and we wanted to solve some problem and one thing led to another. But the transition that I've seen over the last 12 years is phenomenal. A lot of transaction-related work that was being done by human beings is now being done by machines. But that doesn't mean that the human work is gone, right? There's tremendous amount of work that the data science community does in terms of separating the data layer from transaction layer, putting algorithms on top of it to make sense of that data, to drive insights, to drive actionable insights. I'll give you a story. We went to a client and we said, in this particular process, there are 160 people who execute these transactions worth $2 billion. What we are going to do is we're going to actually use a lot of algorithms, some automation componentry around it, and we'll be able to pretty much show you that you are leaving, give or take, $20 million on the table. And client was very excited. Within literally 3 months, we had the contract in our hand. And by the way, within 6 months, we were able to show them first $11 million that there was a revenue leakage in that process. But then what? We took those $11 million back to their salespeople, and we said, in your sales process, you're losing this much money. They said, I have to go and meet my $2 billion number. I don't have time for this $11 million. And CFO was absolutely keen on getting those $11 million. So now the question becomes, they said, okay, so Vikram, what do I do? I paid so much money for you to create these models and the whole application and so on and so forth, but I still can't realize that value. Actually, do you have some people who can go and recover this money? So now all of a sudden, actually I have a different type of ask from my client to actually go negotiate, build relationship with these people, actually understand more from the process as to how can I really eliminate this. right? Whole different new cadre of jobs that are coming up. But by the way, that doesn't put an analytics professional off the hook, and I'll tell you why. The idea here is it's not just about creating models. It's not about just understanding how the data is going to move. Is it going to be a public cloud, private cloud, hybrid, or what kind of architecture I'm going to use? It's not just about that. It's actually about understanding the domain. Unless you are really able to understand the business, right? And particularly the outcome that business drives, the business model, the operating model, it is going to be very, very challenging to actually deliver value from analytics. And by the way, we spend a lot of time. We spend a lot of time cross-educating our analytics professional. By the way, we have 8,000 of analytics professionals who deliver wide variety of services to our clients. But a lot of them actually we hire from what we call domain expertise, whether it's a supply chain professional or a finance and administration professional or trade promotion expertise, somebody has trade promotion expertise. It's extremely critical. And if you have the data science background, if you're an engineer who is building these applications, these systems, solving these large problems, I highly recommend that you got to get deep into domain. Because eventually, what matters is actions. What matters is actually truly creating systems that your end user can trust. Okay? So now, what does that really mean, right? So the way I think about it is we are actually in the world of what we call augmented intelligence, right? Yes, the cost of prediction is going to go down dramatically. But end of the day, you're going to look at that map and predict how much time are you going to take in this Bangalore traffic to get from place A to place B. Correct? You're going to use your tribal knowledge that at this corner, that traffic happens every single day that your Google map or whichever map, favorite map that you have, cannot pick up. Right? Day to day. But that also happens in that sales scenario that I talked about, where actually when we started recovering those $11 million, we were told, actually don't go to this customer. That's a very large customer of mine. I don't want to recover that money. I want to use that as a trigger to sign my next contract. You see, business outcome matters. But working downwards from there, or maybe working upwards, the biggest piece is the data foundation. Depending on where you're working in the stack, right, you got to go up and down the stack and have full understanding of it. Okay? One more advice that I'll give you is that on your resume, don't write the entire stack. I'm serious. I get so many resumes where there's a full table of some 200 technologies. Don't do that. Nobody likes that, right? But you got to have good understanding of it. Okay? The other piece of it is, now you have the data foundation going, the next piece is insights. We've moved on. We need prescriptive insights. Predictive is not enough. We need prescriptive insights. Now, what does that really mean, right? And by the way, it is, in my view, it is flaw of our education system. Okay? Our education system trains managers to look at red, green, yellow and make decisions. Very deterministic way of thinking. Whereas data scientists actually, who use machine learning and artificial intelligence, we all think in now probabilistic manner. Right? I'll give you an example. We are working on a pharma safety application, a very large one. And basically what application does is a case is filed around adverse event, and the machine determines whether that particular case is serious or not. But it says, oh, by the way, I have 80% confidence that this is serious. Now, what should the analyst do? Right? Analyst is confused. And by the way, after developing this whole system, when we went in the test mode, we spent months and months gathering all the requirements, every sign-off, whatever. Then then the customer tells me, actually, this is not usable. My analyst cannot decide whether this is serious or not based on 80% confidence. I want 100% confidence. Now what to do? Right? So they really need prescription. And the processes around it need to be changed. Now you need to teach actually people how to take that probabilistic output and change the way they work. Maybe add more better user experience to it so that they actually still see that red, green, yellow, right? But better trained on what does that really mean if my 80% confidence is being shown on the screen, right? Or my precision and recall for machine learning professionals here are at a certain level, and 20 of the cases that are serious actually go in the non-serious bucket. Then what do I do, right? Normally people get all frazzled, people who are responsible for processes, because they are measured on a different set of metrics, right? Very critical to have these three pieces of the stack very tightly understood as you are developing new applications, new models, solving new problems, right? Because at the end of the day, the outcome of what you create will augment human intelligence. Right? Does that resonate? How many people think that it resonates with them? Right? Day-to-day basis, we are doing this, right? Now, one more piece that we have been kind of working aggressively on is that the repeatability part of it, which is, a lot of companies want to adopt AI and machine learning, and in general, wide variety of advanced data analytics techniques. But what ends up happening is they say that it takes the whole village to bring it to life. Every single time you start from scratch, so to speak, how do we really accelerate this? And especially, I was talking to a colleague here in the speakers lounge, and I said, the way I see it is we are at a very early stage of AI and analytics career. The way the field is progressing, the way investments are going in, actually we are at a fasten your seatbelt moment. We are going to take off even much more aggressively in this field, right? But the value has to be created. And the key part about creating this value is what we call pre-trained accelerators, which is taking that domain knowledge, understanding of the supply chain, understanding of whatever problem that you're solving, and encapsulating it in such a way that it can be used again and again and again. Right? And pre-trained accelerators, by the way, can be created in many different dimensions. Right? Simple thing as data ingestion. How do you create business glossary to ingest that data? Right? Right from there to how do I create repeatable models, right? Of course, without compromising any data privacy, data security, etc. How do I create those models so that I don't have to get the whole village again when I'm solving the next problem and the next problem? And oh, by the way, data pipelines that I'm creating, right? Most companies actually don't have strategies for reusing those data pipelines. How do I create reusable data pipelines? Right? That's what we call pre-trained accelerators. That's where the field is moving. Yeah? So let me give you an example here. We recently partnered with a Formula E racing company called Virgin Racing. And it was a fantastic experience for us. If you might have read Moneyball, a book that is very popular, written by Michael Lewis. If you've not, it's a must-read for every analytics professional. But it's about basically inventing metrics and putting those metrics in action using all kinds of data. It was written for baseball, but we created it for Formula E. Now, what happens here is it's fascinating. You have limited battery, and each driver has limited battery. They need to figure out how to use that battery power as they go around the laps and how to maximize it. Right? They don't get additional battery. That is it. Okay? The second piece is, how do you take competition into consideration so that you are actually winning the race? So what we did was we actually studied lots and lots of driver patterns, if you may, gathered lots and lots of data around each terrain and created an optimizer for the Formula E technician. So every single time, a driver who's sitting at the wheel actually gets advice from a technician who is actually advising them on what to do. For example, if I'm at a particular turn, how much brake should I apply to take that turn so that I'm conserving my energy? Okay? Where should I actually go full throttle so that I'm using minimum amount of energy but getting maximum amount of acceleration? Right? But to do that, our team was actually sitting with the drivers, not sitting in an air-conditioned office and designing these algorithms. It does require domain knowledge, right? Reverse engineering what happens in the field, right? Reverse engineering how those insights, those dashboards, are actually interpreted by the technician. And what is technician really communicating back to the driver? What is useful, what is not useful? Where is driver fumbling versus where technician is kind of filtering the knowledge? You see what I'm saying? And the other side of the equation is now taking all the GPS coordinates of the competitor cars and figuring out who's accelerating where, at what time, so that actually you can create metrics and strategies ahead of time. It's no different than what happens in business, by the way. It's no different than what happens in the business. But this allowed us to kind of do it in a controlled manner. Obviously, there was also a big pride in terms of helping the environment, promoting, the electric car movement, et cetera, and also inventing new set of metrics for a new field or a new type of offering that doesn't exist in the market, right? The other example that I'll give you is around credit decisioning. This was the startup through which I came to Genpact. We created this startup over a period of 12 years. At that time, this was a cool idea. It still is, but we were thrilled when we invented this, which is many times when we go for getting a loan, particularly if you're on the commercial side, getting commercial loan, there are all kinds of documents that you submit, right from income tax statement to financial statements to what have you. And those statements are extracted or they're read by somebody in a normal process. Then a risk model is created at the back of it, and somebody goes and makes a decision whether you should be given a loan or not. It takes 15 days, sometimes 30 days, and it's a frustrating process both for the consumer as well as people who are executing the loan, right? Most importantly, in today's date and time, where we live in the Amazon world, actually, I want instant decision. I don't want to wait for 30 days, right? Otherwise, I'm going to go to somebody else. So it became actually about customer experience. It was not about cost of processing. It was not about creating the best risk model, but it became about customer experience. And what we did here was, again, fully understood what that customer experience looks like or should look like, and work backwards to create all kinds of extraction, NLP processes to process these documents instantly, and created literally what we called instant decisioning process, right? But again, it is about understanding the domain and working full stack to create the solution. Yeah? Another example, completely different example. I'm sure some of you might, who come from banking world might have heard, or even day-to-day basis in your own personal life, you hear KYC, right? Know your customer. Your bank pings you, they want some document from you, et cetera, right? And new regulations continue to come in the banking field every day. And for this client, actually, they came to us and they said, hey, new regulation has come up in Europe and it's coming all over the world, but we need to actually constantly evaluate between the two financial disclosures what's happening with our customer. We constantly need to know how things are changing, right? Because when they applied for loan, they said, hey, I don't have any offices in Middle East. And all of a sudden, new offices showed up in Middle East. How are we going to accommodate for that? How are we going to account for it? How are we going to even know it, right? There was a when we were developing this whole solution, actually we fumbled. We went only with domain expertise because we believed so much in it, right? We actually went in with some deep analytics expertise, but we forgot complete back-end side of it, which is the amount of data that is going to flow in to analyze these events. We did not plan for it. And we created the best model possible, et cetera. But the big lesson learned here was creating the right data foundation. A lot of times it is very hard to estimate what is going to go in. For example, we designed a database that takes 7 million rows of information. Turned out it needed 70 million. Right? Very critical to, again, understand end-to-end. Right? And these are day-to-day mistakes that we as data science professionals make every day. But as the profession is changing, right, it's all about thinking full stack and thinking about how you're going to augment the end user at the other end. Yeah? One final thing I'm going to talk about, while this is about supply chain optimization, but the key here is many a times, our end users, doesn't matter what organization you're working in, their expectation is that a lot of things are going to happen in an automated fashion, right? The moment you say that, oh, I need to actually run this additional script somewhere, they're like, everything happens automated in an automated fashion today. Why? Seems like you don't know what you're doing, right? And we, some of us who know what we are doing, we come in a room and we kind of, commiserate, and then we go back and say, okay, here's the solution. The key here is actually starting with, again, the end user and the customer and setting expectations. A lot of times, setting expectation is the most critical thing. For instance, in this particular case, for a client, actually our goal was to predict what they call case fill rate in a supply chain. How are we going to fulfill the demand that was predicted by certain demand signals? And we created very sort of sophisticated optimization engine, et cetera, and yet there was a gap. And it was supposed to send signals automatically because it was a full stack system for the end user, et cetera. And it did not, right? Because there were some technical challenges because of which you can't really send that signal to so many salespeople in the field. And when we communicated that message to the end customer, they said, what do you mean? Right? I get a notification from FedEx or UPS that your shipment is here. Why can't you do that? Expectation mismatch. Right? Very, very critical to start with end user in mind, business outcome in mind. Right? So that's my key message to this group, that AI and analytics has become a full stack field. It's about augmented intelligence. It's about how do you think about it from top to bottom. So with that, I'll pause and take any questions.
Hi, thank you. My name is Ranga. So your point about how we should start thinking in terms of probabilities really hit home to me. So just an example. So 2 days back, there was an article in Economic Times saying that AI has been used to predict congestive heart failure with 100% accuracy. Now, I just want to know from your experience, in the data science world, have you seen 100% accuracy? Is this a valid claim? Is this something that is even possible?
It's a great question. The first question I would ask is, was it a POC? Right? A lot of these things that come out in media are done for marketing purposes, as we all know. There may be truth to it. I don't know the study. There may be truth to it. 100% accuracy, is it possible? It depends on the data. It depends on the outcome that you're looking for. In some cases, it is possible, right? In fact, in some cases, it is much needed, right? Having said that, it depends on how you define 100% accuracy, right? I mean, we've heard about it in the world of facial recognition, right? Because of ImageNet. Now it is, you know, the machine is doing probably 3% better job than a human being would do on identifying faces or identifying, you know, objects in the images, etc., right? So now what is the benchmark? If the benchmark is, if human being, whatever human being is doing, that's my benchmark of accuracy, then machine is doing 100% accurate work, right? So it's all in the definition, right? And end of the day, it's also in usability, right? So trust but verify, that's what I would say. Other questions?
Just wanted to share a perspective on the recent question on this cancer prediction. So the other thing that we need to look at is related to healthcare and biological processes. And biological processes are more deterministic than probabilistic. So that could also lead to, you know, higher accuracy in those kind of data science applications.
So was it a statement or?
Yeah, just a perspective. So it may be true because, you know, we are predicting or applying data science to biological processes.
That's right.
And how different people react to a drug doesn't differ. You know, if you take a paracetamol, doesn't matter how many people take it, the reaction will be similar. So that kind of variability doesn't exist in biological processes. That could be one reason why you see higher accuracy in data science in healthcare.
I've seen the other way around as well. Many times, actually, same drug taken by 10 different people is absorbed very differently, and it has different outcomes. So it all depends on what you're doing, frankly. It's very subjective.
Hey Vikram, thank you so much for such an insightful session, that's first. And second, my question is related to the POC that you mentioned over here, okay? Now this is one of the problems that we are facing, okay? So I'll go ahead and give you some more details about it. So data science is, I don't want to go and generalize, but still give me some leeway over here. Many of the stakeholders we have seen, they are still a little skeptical about data science because it's like a black box to them. It involves very high degree of mathematics. There are a lot of computations going on, advanced analytics algorithms and all that. So before they go ahead and switch to this data science algorithms, they would want to go ahead and have a POC in place so that they can actually go and take a decision on the basis of that. But problem with the POC is that the data is limited, the sources are limited. So the POC results are not really as accurate. And now coming to the BFS sector, specifically in US where attrition rate is so high, our model pretty much falls flat after 6 months, the POC model that I'm talking about. So it becomes very difficult to go ahead and convince our stakeholders at times that, you know what, it's not so much about the algorithms, it's more about the data that we are actually ingesting over here. How do you, first of all, do you face these kind of problems? And secondly, if yes, then how do you circumvent them? How do you surpass them?
Yeah, this is an everyday problem. So absolutely, what you're talking, it absolutely makes sense. There are two things that I have implemented and that have worked very well. Number one is simplicity. Whatever models that you're creating, whatever system that you're creating, don't complicate it, right? The more assumptions you make in your POC, the more complex models that you create, right, more difficult it is to replicate it in production. Just, simple rule of thumb, right? In fact, when you do the POC, of course, you're very eager to prove out your idea, right? Simpler the better, right? Setting a little lower bar is just fine, okay? The second thing, which actually I would want all of us to pledge and do every day, which is educating the non-data science community. In simple words, the moment you say it is complicated, it is math, it is complex algorithm, the rest of the world tunes out. It sounds like some magic to them, right? But it's math. All of us know how to do math. Doesn't matter what profession you came from, right? Even if you are not actually, if you've not gone to college, and if you're doing some business, you know how to count money. You know how to predict your customer whether you're going to sell certain amount of goods or not. Many people do that intuitively, right? But coaching people, whether it is about AI or machine learning or analytics, in very simple words is very critical. And every single time I have gone and explained it to my end users in simple manner and created simplicity in those POCs, I've been successful. Right? Because they're interested, they're engaged.
Hello, Vikram. I want to ask, how do we make the balance between the human intelligence and the machine outcome? Because the moment we go more into the human intuition, we come to know, okay, you are a data scientist, bring someone from the domain. The moment we go more into the machine outcome, people say, oh, it's too complex, I don't understand that. So how do we make balance in that?
So if I understood your question correctly, what you're saying is that, how do you make the two meet and come up with the right balance?
Right.
Yeah? It's a great question. See, a couple of, again, anecdotal experience related insights, if you may. A couple of things that we've seen is that when it comes to judgment, right, when it is, multi-class problem that a machine, that's very hard to solve with machine, right? When there is human judgment involved around something, right? I would say that human beings are much better at that. Machines have still not solved that problem, right? Machine can probably tell you that, on an X-ray or an MRI, where machine sees the anomaly. It can compare it with 15 other images and tell you that probably this looks like a nodule, right? But what does that really mean, right? In the context of broader system, it comes from human experience. It doesn't come from machine, right? At least as of today, right? Or in the foreseeable future, actually, right? So end of the day, if it is judgment, then I would say that human beings are much better at it. But to arrive at that judgment, all the information number crunching that is necessary, going to 7 different sources, connecting the dots, right? Obviously, machines are better at it because it's very arduous work. And connecting so many, time series data sets, so on and so forth, machine can do that much better, human beings can't, right? So the other two things, negotiation, right? While there are some experiments out there where machines are able to negotiate, kinda, sorta, I think human beings are definitely much better at it.
Yep, okay.
Right? So that would be my answer.
Thank you.
Hi, good morning. I'm Raj Kapadia, and like you rightly said, for a non-technical person like me, so I am from a commerce background, so you made it so easy for me to get the basics of AI through cases which you discussed. So why I am here is that I deal with regulators, the Ministry of Corporate Affairs, and I am a legal professional, basically. So there, in the Ministry of Corporate Affairs, they have come out with a notification that from January next year, they would be starting using AI. So in this year, they have kept a lot of practical checks and balances for corporates, but from next year, they would be using AI for all this. So I just want to get like what could be different going forward. If you can, if you have any idea about it, like from your experience, what can be different from what it is currently? How can they manage using AI?
Yeah. Look, there are many, so by the way, regulators actually are the biggest target for such technologies, if you may. And they have kind of, started adopting it very, very rapidly. The way I look at it is there are many fundamental applications of AI that are fairly mature, right? For example, analyzing legal documents, right? It is fairly mature now. They can rely on it, and more importantly, the speed and the volume at which you analyze those documents. So I would say that, probably that is a starting point, but it's hard to predict where it is going. But the idea is, for us to partner with regulators and educate them and empower them to use systems along with us. Yeah?
Thank you. Thank you.
Next table here.
Hi, I'm Stuti. I'm from pharma background. When you implement a new technology, anything like that, you invest a lot in it. And sometimes the results are like from a POC going to a production are not good enough. You roll back. And that investment really is, it seems we shouldn't have done that. So have you seen such scenarios, and how would you see this coming for a very regulated sector like pharma?
Many times. So seen it many times. Wasted investments. Many times, the POCs looked good, but the end result did not materialize. If at all, pharma industry should be comfortable with it because they invest tremendous amount of money in R&D over a long period of time. Having said that, there's an approach that we have been implementing. We call it agile analytics. So it is taking a little bit of a software development lifecycle, applying it to analytics, and keeping that process more iterative, including actually challenging the hypothesis, challenging the end outcome every quarter or every 6 weeks, depending on the cycle. It makes a lot of sense so that it can avoid you going into pretty much that dead end, if you may. So read up on agile analytics. I think some of those practices help a lot.
Thank you.
Hi. So my question was on, you said we need to set the expectation right at the beginning. But then many times on a day-to-day basis, when you are solving a problem, it so happens that, the expectation is not clear at the beginning. I mean, that keeps changing. And then the same situation arises, oh, it's just a script, you just, accommodate one script, how long it takes to. So how do we tackle such things?
Yeah, I mean, as I was saying earlier, first of all, keep it simple to begin with. Don't make it too complicated to begin with. And work the whole thing backwards in terms of setting expectations, as to right from not just what the end outcome is, but right down to the level of, do you have the data? If you don't have the data, what assumptions are you going to make? And how it is going to progress forward, right? If there is some R&D involved in it, right, which is very likely, be clear about it. Be explicit about it, that this is going to require R&D. It's very hard, by the way. For the end user, for the business owner, it's very hard for them to accept. They're like, what do you mean? I've read in some magazine that you can download open source this, open source that, and we can whip things out in 2 days. But you got to explain to them and educate them that whatever you whip out in 2 days cannot go in production, right? So educating is the key.
Yeah, hi. Yeah, see, the founding principle of predictive analytics is to have a lot of data, right? I mean, you need data to train the model and come up with predictions. But I work with customers who want to create new products, and for example, I work with a customer who is looking at creating a offers mobile app which predicts the next pending event of somebody, right? And then accordingly show up offers to them. So they're asking us to come up with a machine learning solution for them, but they're also a startup. So how do we address such scenarios where the customers also are new and they don't have a lot of data?
Yeah, it's a good question again. Look, when predictions always don't need a lot of data. In some cases, you can come up with a decent prediction with less amount of data. There are techniques that can be used for sparse data. Sometimes you can actually create synthetic data, so you can mimic the customer behavior at the end. So lots of new techniques that have come up. Depending on the scenario, you can use these techniques if you may. But the other piece is also, what we've realized is that getting a model or algorithm out there to get the users to use it so that you can collect more data very rapidly, right? Because once you put it in user's hand, right, you got to set the expectation that this prediction is going to be way off, right? I'm sure you've seen many applications where sometimes they tell you that, apply for this job. I'm not going to name the company. Apply for this job, and this is very suitable to your profile. When you look at it, you're like, really? Right? But over a period of time, over the last year, 18 months, it has become a lot more better because you clicked on it, because you rejected it, right? So sometimes just putting things out there, particularly in consumer applications, is very critical to gather new data very rapidly.
Okay, thank you.
All right, one more question here, and I think I have only 2 minutes left, so.
Hi, good morning.
Hello.
My name is Maitreyi. I'm from Goa Institute of Management. So my question is around the education system that you commented on. You said that the education system needs to be improved, or that is the problem in India. So how do you think we can leverage AI to improve that system, and how to make it better for the good?
Excellent question again. Look, education sector is attracting tremendous amount of investment, as you know. I know personally at least a few companies who have created systems. There's one company called Pragya Systems, actually. Check them out. Who have created some really good systems where of the incoming student, they analyze the entire profile and the background. And they also analyze courses that are being offered in the system and do the matching of the two. And it has benefited them tremendously because no one professor can tell you, or by you scanning 400 courses that are being offered, you can't tell. End of the day, it's your judgment, right? So there is lots of investment that is going on in the ed tech sector to make, to offer students right offering at the right time, if you may. The other piece that I can think of is a lot of feedback systems that are missing in the education system that need to be created, right? Because once you graduate, how many times you go back to your school and provide feedback, right? A lot of those feedback systems are missing, but once you have that, I think it's going to get enriched a lot more. And there are efforts that are going on. Schools are quite aware, so. Okay, very good. Well, thank you very much. I appreciated the morning with you guys. And I'll be available outside if you have questions.